In this video, we're going to start looking at how we can combine functions. And the simplest way to do that is by what we call function arithmetic. So this is using the basic arithmetic operations on functions. So the addition, subtraction, multiplication, and division. We can do these operations on two different functions to create a third new function. Okay. So if we have a function f and a function g, or maybe we'd say f of x and g of x, then f plus g of x. So this is a new function where we've added f and g together. This is defined as simply f of x plus g of x. So all we have to do is take the functions, add them together. No special rules here. So for example, if we have the functions f of x equals x plus 3 and g of x equals x squared minus 5x minus 6, then the new function f plus g of x would be equal to both of these functions added together. So we would get x plus 3. Maybe we group them with parentheses. In this case, it's not really necessary. But with subtraction, it would be a little more helpful. And then we would go ahead and combine the like terms if we can. Okay, so let me just drop the parentheses real quick, not doing anything in this step otherwise. So we have two numbers, right? The 3 and the negative 6, those can be added together. We also have two x terms, the x and the minus 5x. We can combine those. There's no x squared term, so we just leave that one by itself as x squared. X minus 5x would be minus 4x. 3 minus 6 would be negative 3. So ultimately, this new function f plus g of x is equal to x squared minus 4x minus 3. Okay, so we combine two functions to then get a third function. So there's other ways we can do this. Like I said, with the subtraction. So this is going to be similar. F minus g of x is defined as f of x minus g of x. So we simply would take the two functions and subtract them. So in this case, that's going to be x plus 3 minus x squared minus 5x minus 6. The parentheses are a little more helpful here because we have to remember we're subtracting every term in this parentheses, right? We're subtracting all of this. So you can either think of this as doing minus x squared minus negative 5x minus negative 6, or you could go ahead and think of this as a negative 1 in front of here and distribute that negative 1 to every term. Okay, so really doing the same thing, just two different ways of kind of framing it, of thinking about it. So here we'll have x plus 3. If we distribute that negative, we'll have minus x squared plus 5x plus 6. Okay, and then we can combine like terms now that everything is distributed properly. So we have the minus x squared first. We like to write these in descending order, right, with the highest powers first. That's just a convention though. It doesn't have to be followed. But anyway, so x plus 5x then is 6x. 3 plus 6 then is 9. And so we have negative x squared plus 6x plus 9. So we subtract two functions to come up with this third function. Now we're going to do this with multiplication. So we typically would write this as f times g of x, not using any multiplication symbol or whatever. Specifically, we kind of want to try to avoid doing something like f dot g for multiplication. We can write that, but we're going to have a similar notation, which looks like this, f circle g, which can make that kind of confusing. Like it can easily be confused with multiplication. So it's better to just write them right next to each other like this in this context. But when we write f of x times g of x, there's not as much confusion here. So we can go ahead and write it like this with the dot notation. At this point, we pretty much completely ditch the x notation because we're using x as a variable so often and it becomes too confusing. So we go ahead and multiply these. So we've seen this a little bit up to this point. X squared minus 5x minus 6, where we want to use the distributive property now to break this up. So we take x plus 3 and multiply by every term in the x squared, 5x, and 6, right? So we take the whole x plus 3, multiply it by x squared, by minus 5x, by minus 6. So just like we distributed the negative 1, now we're distributing this entire x plus 3. So we would have x plus 3 times x squared plus x plus 3 times negative 5x. Then I'm going to need another line here, plus x plus 3 times negative 6. And then we're going to use the distributive property again. Okay, so now we're going to distribute the x squared to both of the x plus 3 terms, the negative 5x to both of the x plus 3 terms, and same with the minus 6. Okay. So basically what we're trying to do here is we're trying to ensure that every term in the x plus 3 of the binomial here is multiplied by every term in the x squared minus 5x minus 6. Right, so every term should be multiplied by every other term in each parentheses here. So this is an extension of what we sometimes call foiling, if you want to look into that, but that's specifically when we have two of these parentheses with 2 terms. Here we have a 2-term and a 3-term one, but it's just an extension of that. Okay, but ultimately we're just doing the distributive property either way. So anyway, so here we have x squared times x, that'll be x to the 3rd. 3 times x squared will just be 3 times x squared. X times negative 5x will be negative 5x squared. And just as a reminder of why these are true, right? X times x being x squared, this is just the definition of an exponent, right? Exponent means multiply something by itself, however many times the power says. So this is saying multiply x by itself twice. So we write it as x squared. X times x squared. If we break down that first one, that's x times x times x. Right? If we break down the x squared into x times x, I mean. So this is 3 copies of x now, so we get x to the 3rd. Okay. So now we need 3 times negative 5x minus 15x. Negative 6 times x is negative 6x. Negative 6 times 3 is negative 18. Okay. So this is what we have ultimately. We do want to simplify this and combine any like terms that we can. So we get x cubed, 3x squared minus 5x squared will give us a minus 2x squared. Minus 15x minus 6x minus 21x. And then minus 18, there's no other numbers, so we just leave that one here by itself. So we get this new function, which we call f times g. Finally, we will do the division. Now this one's a bit of a special case here. F divided by g of x is still the same thing. It's going to be f of x divided by g of x. But we're introducing a denominator now, right? Which means that we're introducing something that will is going to affect the domain potentially. So we do need to specify that g of x cannot equal 0. So we have to exclude all of those values, which would make g of x equal to 0. Okay. So f of x here was, x plus 3. G of x is x squared minus 5x minus 6. And there's really no simplification to do here necessarily. We're going to look in a separate video at rational expressions where we'll look at fractions with variables and expressions like this, and we'll look to see if there's any way to simplify them. Ultimately, what we need to do is we need to look at, can we factor this bottom one? And that'll be covered in a separate video as well, factoring. And that's also going to lead us to what values of x are going to make this 0, because we need to know those values so that we know which numbers we're excluding to avoid domain issues. So we essentially would be taking the denominator and saying this can't be 0, so let's solve for this. Let's see where it is 0, so we know which numbers are excluded here. So in this case, what we would do is we would break this down as x minus 6, x plus 1. And again, this will be covered in its own video, so this is just kind of a preview of that. So the reason we're able to do this is because now if we were to distribute this, we would get the top quadratic right here is what we call it. So this is kind of like the opposite of doing the foiling or the distributive property, and we call this factoring. So you can check that minus 6 times 1 is negative 6. We would have x times 1, which is x, minus 6 times x, which is negative 6x. Combine those and we would get negative 5x, right? And then x times x would give us x squared. So we're just working backwards here. And then we would use what's called the zero product rule here to say that one of these must be 0 if their product is equal to 0. So we would say x cannot be 6 after we solve these individually, and x cannot be negative 1. So I'm just kind of glossing over it because, like I said, this will be covered in its own video. So our domain here would be all x values except for these two, right? So negative infinity to negative 1, union negative 1 to 6, union 6 to infinity, the domain. And that's very important when we're defining functions this way, because we're introducing that denominator, so we have to exclude those values in order to properly create this function. Just for a simpler example where we don't need to involve any of the factoring or anything like that, so we don't need to gloss over the details, let's just look at g divided by f, right? We can do it the other way as well. So in this case, the x plus 3 is going to be on the bottom. And again, there's no kind of simplifying we need to do here, like how we were combining like terms before. Notice on this one, if we were to factor the bottom, we would have got x minus 6 times x plus 1. That doesn't cancel out with the x plus 3. So there was no simplifying to do. But sometimes one of those factors might cancel out, and then we can do that cancellation, and again, then we would have a simplified expression. Here though, all we need to do is look for where x plus 3 is equal to 0. And that's simpler to do because all we have to do is subtract 3 from both sides, and we get x cannot be 3, or negative 3, sorry. So we would say that this is our function specifying that x cannot be negative 3, right? So our domain then would be negative infinity to negative 3, union negative 3 to infinity.